Hello students, very good morning to all. Once again, I welcomes you all in this online session arranged by Sharad Institute of Technology Polytechnic, Yadrao. As I said, here we learning new course that is Principles of Database. Till now, in the previous sessions, we have completed our first unit that is Basics of Database and Architecture. I just want to recall you all that rather than the notes, you can use these tools as a study material. These are here are some learning websites also, and some reference books are given here. You can see here. And today onwards, we are going to start our second unit, that is data models and database types. But before starting, I want to tell you, in the last unit, you all are achieved our first CO, that is use fundamental concepts of database in database system, and now our goal is to achieve the second CO, that is choose relevant data model to solve a problem. Are you getting that? Here we are going to achieve our second course outcome, and for that we have to achieve these different unit outcomes from this second unit. That is, first unit outcome of this unit is explain the efficiency and storage complexity of the given data models. The second one unit outcome is you will be able to explain the merits and drawbacks of the given data model. And next one is you all are able to convert a given hierarchical database to relational database. And last unit outcome we have to achieve is represent a data set in the given data model graphically. This is our aim in the unit 2. Let's discuss what are the contents of this unit. First one is database models. In database models, we are going to see hierarchical database model, network database model, object-oriented database model. The second point is relational database model. In that, the subpoints are domain, attributes, tuple, and relations. Next and last point of this unit is types of database system. In that, centralized database system, parallel database system, client-server database system, distributed database system. These are the contents of our second unit. Let's start with the 2.1 database models. What is database model? Database model, in short, the short answer of this is database model is a structure or a format for a database. In first unit, you have seen that what is database, and for that database there is one particular structure or a format that is called as a database model. Also, we can say that a database model defines the logical design and structure of database and defines how data will be stored, accessed, and updated in a database management system. It describes the design of database to reflect entities, attributes, relationship among data, constraints, and so on. While the relational model is the most widely used database model, there are other models too. Data models define how the logical structure of database is modeled. Database models are fundamental entities to introduce abstraction in database management system. Data models define how data is connected to each other and how they are processed and stored inside the system. The very first data model could be flat data model, where all the data used are to be kept in the same plane. Earlier data models were not so scientific, hence they were prone to introduce lots of duplication and update anomalies. Data model can be defined as integrated collection of concepts for describing and manipulating data, relationships between data, and constraints on the data in an organization. Or you can say a data model comprises of three components. First, a structural part, second, manipulative part, and third, possibly a set of integrity rules. What is the structural part? It consisting of set of rules according to which databases can be constructed. Second one is a manipulative part, defining the types of operation that are allowed on the data, like the operations that are used for updating or retrieving data from the database and for changing the structure of the database. And the next one, possibly a set of integrity rules which ensures that the data is accurate. The purpose of data model is to represent data and to make the data understandable. There have been many data models proposed. They fall into three broad categories. There are several types of data models in the database management system. We will cover them in detail. In this session, we will just see a basic overview of types of models. The three types of database models are object-based data model, physical data model, and record-based data models. Here you can see the hierarchical structure of data models. Data models are categorized into three types. First one, object-based data model, record-based data model, and physical data model. And the object-based data model is again categorized into two types, entity relationship model, object-oriented model, and the record-based data model is containing three types, relational model, network model, hierarchical model. First, we will see what is object-based data model, what is record-based data model, and what is physical data model. In our syllabus, that is in 2.1, we have to study only three models, that is hierarchical database model, network database model, and object-oriented database model in detail. Let's see object-based logical model. Object-based models describe data at the conceptual and view level. That is, object-based data models use concepts such as entities, attributes, and relationships. An entity is a distinct object in the organization that is to be represented in the database. An attribute is the property of that described some aspect of the object that we wish to record. And a relationship is an association between entities. Or you can say object-based model and record-based models. Object-based models describe data at the logical and view level of database. It is used to describe logical data structure. There are two subtypes of object-based models. That is, first one is ER model, called as the entity relationship model, and second one is object-oriented model. We have to study object-oriented model in detail. The second one model is record-based model. Record-based logical model are used in describing data at the logical and view level. In contrast to object-based data models, they are used to specify the overall logical structure of the database and to provide a higher level description of the implementation. Record-based models are so named because the database is structured in fixed format records of several types. Each record defines a fixed number of fields or attributes, and each field is usually of fixed length. Also, like object-based model, they describe data at the conceptual and view level. These models specify logical structure of database with records, fields, and attributes. The three most widely accepted record-based data models are: first one, hierarchical model, relational model, and network model. In this, we have to study hierarchical model and network model in detail for our course. And third one is physical data models. Physical data models describe how data is stored in the computer, representing information such as a record structure, record ordering, and access paths. These are not as many physical data models as logical data models, the most common one being the unifying model. Physical data models, you can say these models describe data at the lowest level of abstraction. This is all about the data models. Now we will discuss the first model, that is hierarchical database model. This model was primarily used by IBM information management systems in the 60s and 70s, but they are rarely seen today due to certain operational inefficiencies. Hierarchical model was the first database management system model. This model organizes the data in the hierarchical tree structure. The hierarchy starts from the root, which has root data, and then it expands in the form of tree, adding child node to the parent node. This model easily represents some of the real world relationships like food recipes, sitemap of a website, and so on. Also, this model defines like this database model organizes data into a tree-like structure with a single root to which all other data is linked. The hierarchy starts from the root data and expands like a tree, adding child nodes to the parent nodes. In this model, a child node will only have a single parent node. This model efficiently describes many real-world relationships like index of book, recipes, and so on. In hierarchical model, data is organized into tree-like structure with one-to-many relationships between two different types of data. Here you have to remember, you must remember that the hierarchical model uses one-to-many relationships between two types of data. Let's discuss different features of the hierarchical model. The first one is one-to-many relationship. The data here is organized in a tree-like structure where the one-to-many relationship is between the data types. Also, there can be only one path from parent to any node. Second one feature is parent-child relationship. Each child node has a parent node, but a parent node can have more than one child node. Multiple parents are not allowed here. Third one is deletion problem. If a parent node is deleted, then the child node is automatically deleted. And last one is pointers. Pointers are used to link the parent node with the child node and are used to navigate between the stored data. Here you can see the example of hierarchical database model. Here data is organized into tree-like structure with one-to-many relationship between two different data types. Like one department can have many courses. The example is likewise college. Here a college is having one departments and infrastructure. The departments, one department is having multiple courses, teachers, students. The courses having again multiple parts like theory, labs, and so on. This is the example of hierarchical database model. Now we will see advantages of hierarchical database model. The model allows easy addition and deletion of new information. Second one advantage is data at the top of hierarchy is very fast to access, that is at the root level. Next one, it was very easy to work with the model because it worked well with linear type data storage such as tapes. Next one advantage is the model relates very well to natural hierarchies such as assembly plants and employee organization in corporations. Next, it relates well to anything that works through a one-to-many relationship. For example, there is a president with many managers below them and those managers have many employees below them. But each employee has only one manager. This is all about the advantages of hierarchical database model. Also you can add it is very simple and fast to traverse through a tree-like structure. Any change in the parent node is automatically reflected in the child node, so the integrity of data is maintained. The main advantage is performance, navigating among the records in the hierarchical database is very fast because the parent-child relationships are implemented with pointers from one data record to another. The same is true for the sideways relationships from child to child and parent to parent. Thus, after finding the first record, the program does not have to search an index to find the next record. Instead, the application needs only to follow one of the multiple child record pointers, the single sibling record pointer or the single parent record pointer to get the next record. That is called as a better performance. And next one is ease of understanding. The organization of the database parallels a corporate organization chart or a family tree. As such, it has a familiar feel to even non-programmers. Moreover, it easily depicts relationship between A is a part of B. The case with the order database we discussed where each data item was a part of an order. These are the main advantages of hierarchical database model. Now we will see disadvantages of hierarchical database model. This model has many issues that hold it back now that we require more sophisticated relationships. Second one disadvantage is it requires data to be repetitively stored in many different entities. Next one is the database can be very slow when searching for information on the lower entities like child entities, siblings. Next one is we no longer use linear data storage mediums such as the tapes, so that advantage is null. Next disadvantage of hierarchical database model is searching for data queries. The database management system to run through the entire model from top to bottom until the required information is found, making queries very slow. Next one is can only model one-to-many relationships. Many-to-many relationships are not supported. And last one is clever manipulation of the model are required to make many-to-many relationships. Also, this is the complex relationships are not supported in this type of model as it does not support more than one parent of the child node. So, if we have some complex relationship where a child node needs to have two parent node, then that can't be represented using this model. And next one disadvantage is if a parent node is deleted, then the child node is automatically deleted. It's also one of the main disadvantage of this model. Let's end this point with another one example. Here you can see the hierarchical model for shoes present on a shopping website in the following way. The main root node is shoes. Next one is next one point is there are two childs for that shoes, women's shoes, men's shoes. These are called as the childs, and again women's shoes and men's shoes having parts high heels, bellies, and men's shoes contains sports shoes and sneakers. In this example, if you want to go to the node sneakers, we only have one path to reach there, that is through main shoes node. In this example, the shoes node points to the two other nodes, main shoes node and main shoes node. There at this time we use pointers. This is all about the hierarchical database model. Now let's start with the network database model. Network database model was invented by Charles Bachman in 1969 as an enhancement of the already existing database model, that is hierarchical database model. Because the hierarchical database model was highly flawed, Bachman decided to create a database that is similar to the hierarchical database but with more flexibility and less defaults. The original and existing hierarchical database has one owner file linked strictly to one member file, creating a ladder effect that restricted the database to find relationship outside of its category. A network database model is a database model that allows multiple records to be linked to the same owner file. The model can be seen as an upside down tree where the branches are the member information linked to the owner, which is the bottom of the tree. The multiple linkages which this information allows the network database model to be very flexible. In addition, the relationships that the information has in the network database model is defined as, remember, in hierarchical model the relationship is one to many, but in network model it termed as many to many relationship because one owner file can be linked to many member files and vice versa. This model, in short, you can say this model is an extension of the hierarchical model. It was the most popular model before the relational model. This model is same as the hierarchical model. The only difference is that record can have more than one parent. It replaces the hierarchical tree with a graph. Here you can see how the network model works. That node A is connected to B1 and B2, and again that B1 and B2 are connected to C1, C2, C3. Means here is the strong network, and also there is more than one parent for a child. This was the most widely used database model before relational model was introduced. Now let's discuss the features of the network model. First one is ability to merge more relationships. In this model, as there are more relationships, so data is more related. This model has the ability to manage one-to-one relationship as well as many-to-many relationships. The second one feature is many paths. As there are more relationships, so there can be more than one path to the same record. This makes data access fast and simple. And the last one feature is circular linked list. The operations on the network model are done with the help of circular linked list. The current position is maintained with the help of program, and this position navigates through the records according to the relationships. Here is the example of network database model. In this example, we can see that node student has two parents, that is CSE department and library, and such multiple parenting is not possible in the hierarchical model. That's why network database model gets introduced. Are you getting that? Why network database model gets introduced? To overcome the hierarchical database model problems, network database model gets introduced. Now, advantages of network database model. First one, high speed. It provides very efficient high speed retrieval. Second one, simplicity. The network model is conceptually simple and easy to design. Next, ability to handle more relationship types. The network model can handle the one-to-many and many-to-many relationships. Ease of data access, data integrity. That is, as there is a parent-child relationship, so data integrity is present. Any change in parent record is reflected in the child record. And data independence. The network model draws a clear line of demarcation between programs and the complex physical storage details. Now we will see disadvantages of network database model. System complexity. In a network model, data are accessed one record at a time. This makes it essential for the database designers, administrators and programmers to be familiar with the internal data structure to gain access to the data. Therefore, user-friendly database management system cannot be created using network model. As more and more relationships need to be handled, the system might get complex. So, a user must be having detailed knowledge of the model to work with the model. Next one is any changes like updation, deletion, insertion is very complex. And lack of structural independence is there. This is all about the network database model. The next point is comparison between hierarchical database model and network database model. If you are clear with the concept of hierarchical database model and the network database model, then you can easily compare these two models. The first one difference is in hierarchical database model there is a one-to-many relationship, and in network database model there is many-to-many relationship between the data. Next one is hierarchical database model is difficult to navigate because of its strict owner to member connection, and network database model is easily accessed because the linkage between the information. The next one difference is hierarchical database model having less flexibility with the collection of information because of the hierarchical position of the files. And the next in the network database model having great flexibility among the information files because the multiple relationships among the files. Next one is hierarchical database model uses pointers to relate data, and in network database model it uses links to relate the data. And last one difference is that hierarchical database model is based on tree-like structure with one root, and network database model is based on records and links. These are few points of comparison between these two models. And now today's last point of data model, that is object oriented database model. Object oriented database models have been around mid 1970 when the concept of object oriented programming was first explored. It is only in the last 10 or 15 years that companies are utilizing object-oriented database management systems. An object database is a database management system in which information is represented in the form of objects as used in the object-oriented programming. Object databases are different from relational databases, which are table-oriented. Object relational databases are a hybrid of both approaches. The real-world problems are more closely represented through the object-oriented data model. In this model, both the data and relationship are present in a single structure known as object. We can store audio, video, images, etc. in the database, which was not possible in the relational model. In this model, two or more objects are connected through links. We use this link to relate one object to another object. The object-oriented model is based on collection of objects. An object contains values stored in instances variable within the object. An object contains bodies of code that operate on the object. We can be understand by the example given here. In this example, we have two objects, employee and department. All the data and relationships of each object are contained as a single unit. The attributes like name, job title of the employee, and the methods which will be performed by that object are stored as a single object. The two objects are connected through a common attribute, that is the department ID, and the communication between these two will be done with the help of this common ID. And now, advantages of object-oriented database model. Reduce the maintenance. The primary goal of object-oriented development is the assurance that the system will enjoy a longer life while having far smaller maintenance costs, because most of the processes within the system are encapsulated. The behaviors may be reused and incorporated into new behaviors. Real world modeling. Next one is real world modeling. Object-oriented system tends to model the real world in a more complete fashion than do traditional methods. That is because of its and next one is because of its inheritance property. We can reuse the attributes and functionalities. It reduces the cost of maintaining the same data multiple times. Also, these informations are encapsulated and there is no fear being misused by other objects. If we need any new feature, we can easily add new class inherited from parent class and adds new features. Hence, it reduces the overhead and maintenance cost. Next one is because of the above feature, that is inheritance, it becomes more flexible in the case of any changes. Next one is codes are reused because of inheritance, and since each class binds its attributes and its functionality, it is same as representing the real world object. We can see each object as a real entity, hence it is more understandable. And that's why it gives improved performance. There have been a number of benchmarks that have suggested in this provide significant performance improvements over relational database management system. And now here the last point is disadvantages of object-oriented database model, like lack of universal data model, lack of experience, competition, complexity, lack of support for security. It is not widely developed and complete to use in the database system. Hence, it is not accepted by the users. Next one disadvantage is it is an approach for solving the requirement. It is not a technology. Hence, it fails to put it in the database management system. Lack of support and for security, like currently Object-oriented database model systems do not provide adequate security mechanisms. The user cannot grant access rights on individual objects or classes. There is also complexities there. The increased functionality provided by the object-oriented database model system, such as the illusion of the single-level storage model, pointer sizzling, long-duration transactions, version management, and schema evaluation makes the system more complex than that of traditional database management systems. In complexity leads to produce that are more expensive and more difficult to use. This is all about the object-oriented database model. In the next session, we will continue with the new points, relational database model. In that domain, attributes, tuples, and relations in detail. Thank you. Thank you so much.